The overall goal of this procedure is to produce a new class of cellulose-based nanoparticles and biopolymers, including a unique nanocrystalline cellulose that bears both crystalline and amorphous parts, and is thus called hairy nanocrystalline cellulose.
This method can help provide key building blocks to advance the sustainable nanotechnology field. The main advantage of this technique is that through simple chemical reactions, cellulose fibers are converted to highly functional nanoparticles and biopolymers.
The invention of hairy nanocrystalline cellulose has introduced a new opportunity to use cellulose, the most abundant biopolymer in the world, for advanced applications such as bio-nanocomposites, rheology modifiers, use in environmental remediation, hydrogels, and much more.
Hairy nanocrystalline cellulose can be prepared as anionic, neutral, or cationic nanoparticles, each of which has its own unique properties.
To begin, tear up Q90 softwood pulp sheets into approximately 2 cm square pieces. Collect 4 grams and soak the pieces in water for at least 24 hours while stirring. Once soaked, use a mechanical disintegrator for about 3 minutes to make a near-uniform dispersion of pulp in solution. Next, use a vacuum filter composed of a 20-micron nylon filter in a Buchner funnel to separate the disintegrated pulp from the liquid. Then, weigh the wet pulp and calculate the amount of adsorbed